Everyone. In this video, I am going to discuss about design of microstrip passive antenna working at a 3.6 gigahertz. First of all, we are going to draw that substrate. We already know microstrip antenna contain three layers. First one is the ground layer, middle layer is that substrate, then and top layer is that patch layer. First of all, we are going to draw the substrate. So we have to pick that box. Here you press any place on the project window. Then go to box, change that name substrate. Here instead of vacuum you select FR for material. Why? Because it is only easily available. Then you give OK, you change that color, whatever color you want you change that color, then you give OK, apply, OK. Then go to within that substrate. Here you want to give that position and length and width of that patch. Here position is that minus 39 by 2 comma minus 47.6 by 2 comma 0. Then x is that width of that substrate 39, y is the length of the substrate, you give 47.6. Height of the substrate is 1.6 because here you are taking the substrate is the FR4 substrate. Okay, after that you press Ctrl D means that when that antenna size come within that project window. Then you rotate this substrate because you want to draw that ground. After that you press Ctrl D, then go to rectangle. Here you select select the face. In that go you change that name, instead of rectangular one you give ground. You give any color. I am giving here green color. Whatever color you want you give that color. Within that you see here automatically length and width of the ground, that position is automatically fixed within that bottom of that substrate. Then you are going to draw that patch. Patch is the top of the substrate, so you rotate this object. Within the top only we are going to draw that substrate, sorry, a patch. Then patch you select a rectangle, you draw, you click any place on the project window, then go to rectangular one, you change that name patch. Here you give change any color, apply, okay. Then you change that position and length and width of the patch. Here I am position of the patch is minus 29.443 by 2. Sorry, minus 29.443 by 2 comma minus 38.03 by 2 comma 1.6. okay, why you are giving here 1.6 and that height of the substrate is 1.6. Here you give that length and width of that substrate 29.443. Then you give 38.03. Then you give apply. Then you give OK. See here, this is that patch layer. Next we are going to draw the feed position of that patch. So you select that rectangle, you draw any place on that project window. Instead of rectangular one, you change feed. Here you change the color is whatever color you want, you change the color. Apply, OK. Then you give that length and width of that position of that patch. Here I am going to uh, give length and width of that field line is 5 and y is that 3. Then position of that patch is 14.5 comma minus 1.5 comma 1.6 because the height of that substrate. Okay, 1.6. Then you give apply, then you give OK. Sorry, you select feed position. Here only you want to change that value. Already I done that mistake. Instead of feed, I give that length and width of that patch. So carefully you give that value. In that feed only we are going to change that value. Here position of the feed is 14.5 comma minus 1.5 comma 1.6. This is the height of the substrate, 1.6. Then you give 5 and 3. Then you give apply, then you give OK. This is that feed position. Then patch and feed position in that same layer. Okay, so you have to you need patch and feed. You press Control, then you select patch and feed, then go to edit boolean, you give unite. Now you see here patch and feed position is united. Why you are adding the patch and feed position means here only the feed only you have to give that current without adding the patch is not radiating perfectly, so we have to add feed and patch of that layer. Okay, now we are going to give that feed position. Before you want to give that feed position, here you select that y set, because this is here only you want to give that feed. This is the z, this is y axis. Okay, zoom it, then go to rectangle. Here you select, this is your feed position. Instead of rectangular one, you give port. Here you change that any color. You give apply, then you give OK. Here instead of 3.5, you give 3. Why? Because the width is changed. See here, now that feed position and port of that patches matches exactly. Then you have to apply that, assign that excitation. So go to assign excitation, you give lumped port, then give next new line. Here bottom one click, top one click, then next finish. See in that excitation you check here. Now port is assigned. Next one you have to assign perfect electric conductor of ground. So select that ground, go to assign boundary and give perfect E, then you give OK. After that patch, you select the patch, assign boundary perfect E, then you give OK. After that you want to assign that radiation box. For assigning radiation box, in that project window you right click, create open region. Here you give operating frequency is 3.6 gigahertz, then you give OK. Here radiation box is assigned. Instead of vacuum, here vacuum is there. Instead of vacuum you give air, because antenna is radiating in that air, free space region only, so you have to select air, then you give OK. You give transparency is more, 0.9, then you give apply, then you give OK, then you press Ctrl D, means within that project window itself. Okay, then go to analysis, add solution setup. Instead of 5 you have to give 3.6 gigahertz, then you give OK. After that, in that setup one you right click the setup one, add frequency sweep. Instead of 10 gigahertz you give 5. Okay, now operating range is 3.6 gigahertz, so you give here 1 to 5 gigahertz. Then go to HFSS, you give validation check, then go to HFSS, you give analyze all. Now you save that file, you take any one places, you save your file. Now now simulation is going on, you have to wait some time, it will take some time, so you have to wait. Now antenna is simulated. After simulation, go to results, create model solution data report. You select rectangular plot, here you select the S parameter, then you give new report, then you give close, means go right click marker, you add marker. See here exactly that 3.6 gigahertz the antenna is resonating at frequency is minus 21, return loss value is minus 21. Then you want to see that VSWR, means same thing, you go to that model setup, create model solution data report. In that rectangular plot, here instead of S parameter you select VSWR, then you give new report, then you give close. Then similarly go to marker, add marker, here you select here at see here at 3.6, go to marker, add marker, see at 3.6, that VSWR range is 1.1924. Okay,